Welcome to today's lesson on energy and how the energy moves between different stores. We'll explore how energy, although invisible, can be transferred from one store to another while always obeying the principle of conservation of energy. Energy is something that we cannot see, but it exists everywhere. It can be stored in different stores like kinetic store, internal store, elastic potential store, chemical potential store, gravitational potential store, and nuclear store. Although we can't directly see energy, we can observe its effects, such as motion or temperature changes. According to the principle of conservation of energy, the total energy in a system remains constant. If energy is transferred from one store to another, the total amount of energy will stay the same. For example, if we have 1 million joules of energy in the chemical potential store in the food that we eat, a maximum of 1 million joules can be transferred to energy in the kinetic store when we run. The total energy in both stores must remain constant before and after the transfer. Another example: there is 100 joules of energy in the kinetic store of the wind blowing against a windmill. A maximum of 100 joules of energy can be transferred to energy in the kinetic store of the windmill. The total energy in both stores must remain constant before and after the transfer. Now let's look at how energy can move between stores. There are 4 different modes of energy transfer: mechanically by a force, through heating due to a temperature difference, by electromagnetic waves or mechanical sound waves, and electrically by electric current. Each of these modes of transfer works in a unique way. Energy can be transferred mechanically, which means using a force to move an object over a distance. For example, when you push a box, energy is transferred from your muscles to the box, making it move. We say that energy from the chemical potential store of the man is transferred mechanically by a force over a distance to the energy in the kinetic store of the box. Energy can also be transferred through heating when there's a difference in temperature. Heat always moves from a hotter object to a cooler one, like when heat from the environment is transferred to the ice and the ice melts. We say that energy in the internal store of the environment is transferred by heating due to a temperature difference between the environment and the ice to the energy in the internal store of the ice. Another way energy can be transferred is by waves. For example, when you listen to music, mechanical sound waves carry energy from the speaker to your ears. We say that energy in the kinetic store of the air is transferred by propagation of mechanical sound waves to the energy in the kinetic store of the eardrum. Another example: when the sun shines on the road, electromagnetic waves carry energy from the sun to the road, causing the road to heat up. We say that energy in the nuclear store of the sun is transferred by propagation of electromagnetic waves to the energy in the internal store of the road. The 4th mode of energy transfer is by electric current. When the switch is closed, the electric current flows from the battery to the resistor, causing the resistor to heat up. We say that energy in the chemical potential store of the battery is transferred electrically by electric current to energy in the internal store of the resistor. To recap, energy can be transferred in 4 main ways: mechanically by a force, by heating due to a temperature difference, through electromagnetic waves or mechanical sound waves, and electrically by electric current. Remember, the total energy remains the same even though it might move between stores.